Hi, my name is Shomrik Bhattacharya and I'm from Calcutta, India. I always had this innate urge to yank open electrical gadgets and inspect what's inside them. I had physics in my high school and was introduced to resistors, capacitors, inductors, and semiconductors then. 622X has changed my life forever. Now I know how gadgets work under the hood. My CECC5 project is an automatic nightlight. So the materials required are capacitors, a 330 nanofarad and 100 nanofarad. Then resistors, 330 ohm, 4.7 kilo ohm, 1 kilo ohm and 470 ohms. A battery, 9 volt. An LDR, light dependent resistor, which is this, an LDR, and transistors, 2 transistors of BC547 and an IC LM7806, which is this. Both the transistors and the ICs are from Fairchild. A red LED and connecting wires and clips and breadboard. So what exactly is an LDR? So LDR is a light dependent resistor. It behaves according to the ambient light. So this is also called a photoresistor. So LDR senses the presence of light and uses its output to control the transistor, which turns the LED on. When light falls on the LDR, it pulls down the voltage, bypassing the transistor, and thus the LED does not light up. So this is the circuit diagram of a light activated LDR. When light falls on it, some 15 milliamperes of current flows through the circuit. The current passes through the transistor and the LED turns on. The transistor is in the on state and the LED turns on. When we interchange the position of the preset resistor and the LDR, this setup becomes dark activated LDR. When it's dark, it turns on. When there is ambient light, it turns off, just because the pull up pull down phases becomes vice versa. So this is how an LDR works. And the LDR used, the photoresistor used, is this one. Very small sized photoresistor. So next up we have the ICs and the transistors. So the transistor I've used is a Fairchild BC547. This is a NPN bipolar junction transistor, mainly used for amplification switching purposes. So here we are using it for switching purposes. This is the pin diagram of the transistor, the CBE, collector, base and emitter. So how does a transistor really work? This is actually the graph of the VBE versus IB characteristic graph of transistor, IB versus VBE characteristic. Here we have the threshold voltage, which is approximately ranges from 0.7 to 0.9 volts in these silicon based transistors. So you can see there is no current, there is no voltage when the VBE is less than 0.7 volt, which is less than the threshold voltage. As VBE crosses 0.7 volt, the current increases exponentially for small increases in the VBE. So then the transistor moves on to the saturation point. And here we have the graph of VCE, IC versus VCE. We have the it saturates at some point for specific values of IB, which ranges in microamperes. Here we have the saturation cutoff points and saturation regions. So analytically, how do we know how a transistor works? Think of a transistor as something like a box with a wall in between, a water gate kind of wall, and you pour in current, which is like the form of water. You pour in current, and the current and the water level increases, so the current level increases, but there is a threshold. Once we cross this level, then the current will flow to the other side. So as you keep on pouring water, and as the threshold increases, the the water flows over here. So does the analogy of current. As we have more of current flowing in, as it crosses the threshold voltage, the current starts flowing and the transistor moves to the on state. And when the transistor behaves as a switch, it has an active region and saturation region. When it behaves as an amplifier, it is an active mode. So here we have on or off state. When the current crosses a threshold, it jumps over this wall, and the transistor becomes on. And this one is Fairchild LM7806 IC. This is a 3-terminal positive regulator IC with an output of around 6 volts. So now here we have our circuit diagram. So this portion of the circuit was the trickiest portion of the circuit. All the Fairchild devices I'm using uses a 6 volt input. Firstly, I faced the problem of stepping down the circuit's voltage. All the Fairchild uses 6 volt, and 6 volt battery was nowhere to be found. I could just get a 9 volt battery. So I bought one of these, a transformer. But I was wary of blowing things up. Everything might go poof. So I did not use it ultimately. Then some bit of abstraction, some trial and error, problem solving, I got to know that these combinations of capacitors, 330 nanofarad and 100 nanofarad, would work, and this LM7806 has a 6 volt output for 12 or 9 volt inputs. So I use these, and this portion converts 9 volt to 6 volt. And here you have the ground, and between the ground and this portion you have a 6 volt of potential difference. The rest of the circuit is the LDR circuit, the light dependent LED circuit. Here we have the LDR. We have 4 resistors over here. This is kind of the preset resistor. The true transistors are over here, and the LEDs over here. So as the light falls on the LDR, the current is pulled up. It bypasses the transistor, and current does not flow through the transistor. It does not cross the VBE level, the voltage does not cross the threshold level, and the transistor is in the off state. No current is flowing to the LED, and the LED is not glowing. But when it's dark, current is flowing through the transistor. Transistor is in the on state. Current flows through here. It passes through the LED. The LED glows up. So this has specific uses for outdoor purposes. So now here we have our breadboard implementation of my circuit. So this is the breadboard implementation of my circuit. So I'll just connect. I've used this kind of tape kind of thing, paper covering to cover my photoresistor. So I'll just plug in my battery, and I'll cover the photoresistor, and when there's ambient light, the LED does not glow. When I cover the ambient light, the LED glows. I remove my hand, there's ambient light going in through there, the photoresistor is activated, and current is bypassed from this first transistor, and it does not move to the subsequent portions of the circuit. But when I put my hand, cover the photoresistor, then current passes through the transistor through the rest of the circuit, and the circuit is completed, and the LED glows up, as you can see. Yeah, quite funny, isn't it? You can play for it all day long. Yeah. So here we have the battery. It goes in there, the positive red and the negative black. This is the conversion portion. This is the LM7806 IC. The capacitors are over here. We get a 6 volt inputs over here and here. Then this is the 330 ohm resistor. Here we have the photoresistor. This is the preset resistor. The transistor is over here. Then we have the LED and the resistor connected in series with the LED, the 470 ohm resistor. Then the couple of transistors over here. So this is what it is: conversion and the rest of the circuit. Just as I block the path of light, it glows up. Just as I remove my hand, it switches off. This will keep your electricity bill low. So even if there is light, current flows through it, but only about 1.5 milliamps of current flows through it, and the voltage is not enough to cross the VB, is not enough to cross the threshold level of the transistor, the BC547 transistor. But when it's dark, about 15 milliamps of current flows through it, around 10 times the current flows through it. So the transistor's VBE crosses the threshold level, and it saturates and becomes on state. So this is what it is. Okay, so this would not have been possible without 602X, Professor Agarwal, MIT, edX, all the TAs associated with the course, and all my classmates. Whose discussions have been invaluable for my education. I am totally excited about the future offerings and the advancements in these topic from edX, and indebted to MIT and edX for bringing up something like this to us, to our computers, to our homes, where we do not have the resources of this stature. Thanks a lot. I'll be enjoying with my circuit and playing all day long. Thanks a lot. I'm armed with new gadgets. Thanks a lot, 622X. Thank you.